In this presentation, we will provide information about lean transformation. In this content, we will explore the basic concepts of lean philosophy, the building blocks of the Toyota production system, and the lean value concept. Additionally, we will focus on the waste reduction, the continuous improvement culture, and the contributions of lean tools to businesses. Lean philosophy is a mindset that aims to offer the highest value to the customer with the least amount of resources. This approach is based on eliminating waste and ensuring continuous improvement. Developed by Toyota in the 1950s, this system led to profound changes in manufacturing processes to increase efficiency. The key point is this: lean philosophy is customer-oriented, data-driven, and process-based. Decisions are shaped according to customer needs, and processes are constantly reviewed accordingly. Lean philosophy has two main principles: just-in-time and Jidoka. These principles form the core of the Toyota production system. The just-in-time principle aims to produce the required product in the required amount and just in time. By eliminating unnecessary stocks and waiting times, it ensures a smooth and efficient process. This allows for quick and accurate responses to customer demands. Jidoka places quality within the process. It gives the authority to stop production when a problem occurs. This ensures that errors are detected before they develop and resolved immediately. It also refers to machines becoming intelligent while human control remains active at all times. When these two principles are combined with the principles of continuous improvement, Kaizen, and respect for people, they demonstrate the power of lean philosophy. Value is everything that directly meets the customer's needs and, as a result, they are willing to pay for it. A product or service is considered valuable if it solves the customer's problem, meets their expectations, or provides benefits to them. If the customer says, yes, it's worth paying for, that process or output has genuinely created value. Waste encompasses all activities that do not change the physical structure of the product, do not improve its quality, and are not something the customer is willing to pay for. These types of activities consume resources but do not create value. In contrast, value-added activities are those that change the physical structure of the product, improve its quality, and are processes the customer is willing to pay for. These activities provide direct contributions to the customer. There are also activities that do not add value but are necessary for the process. These may not affect the quality or physical structure but may be essential for the continuity of processes in the existing system. However, the customer does not want to pay for these activities. Therefore, our goal is clear. The main objective of lean thinking is to creating value for the customer. Producing products or services that meet the real needs of the customer, provide benefits, and that they are willing to pay for is the starting point of the entire process. However, unnecessary steps in processes, i.e., waste, should also be eliminated. This means eliminating all activities that consume resources but do not add value, such as waiting, overproduction, and unnecessary movement. Lean thinking aims to improve not only today but also the future. For this reason, the culture of continuous improvement encourages daily growth through small but effective steps. Teamwork and participation are indispensable for the success of lean thinking. The contribution of each individual to the process increases the sustainability of development. In lean philosophy, value is what the customer really wants. These are the elements that fulfill their needs and expectations. Everything that is worthless to the customer is considered waste. Lean thinking aims to eliminate waste by identifying it. It involves revisioning all the steps in the creation process of a product or service. Each of these processes should add value to the customer. The pull system ensures that production is only done based on actual needs. In this system, production starts only based on customer demand, ensuring that stock levels are kept to a minimum. The pull system eliminates waste by preventing unnecessary production. Continuous improvement, Kaizen is an approach where employees contribute to processes at all levels, aiming for continuous development through small but effective changes. Kaizen allows small steps taken every day to lead to major improvements over time. This is one of the key principles of lean thinking and helps make processes more efficient and effective. The foundation of Japan's success in competition lies in the philosophy of maintaining and improving standards. This philosophy is based on the belief that work is futile if standards are not met. In other words, it is crucial to establish standards for processes to work smoothly and continuously improve those standards. The Japanese management approach not only increases efficiency but also enhances employee participation and motivation. As employees stick to the standards, both individual and organizational success is achieved. According to lean philosophy, waste is anything that does not create value. Overproduction refers to production done beyond the required amount or ahead of the needed time, and leads to unnecessary costs. Inventory is the accumulation of excess stock, which increases transportation and storage costs. Overprocessing points to the existence of worthless steps and extends processes. Defects require rework and leads to time loss. Motion results in labor waste, while transportation makes unnecessary movement of products. Waiting shows delays in processes, while underutilized skills indicate the failure to fully use employee potential. All these wastes decrease process efficiency and hinder efforts to create value. Overproduction refers producing more than what is needed or before it is actually needed. There are several key reasons for this. First, long adjustment times make large batch production attractive. Long durations can lead to more products being produced in an attempt to speed up the production process. Another reason is unbalanced workstations. Imbalances at workstations can lead to overproduction. Lastly, demand estimation errors can also result in overproduction. Incorrect forecasts increase production quantities, causing waste. Overproduction not only leads to resource waste but can also cause customer dissatisfaction. Inventory refers to raw materials, intermediate products, or finished products held in excess of the amount required during the production and delivery processes. The main reasons for excess inventory include overproduction, producing more than the required amount, excessive purchasing due to supplier security concerns, and high minimum purchase order quantity. Additionally, defective product recipes and inactive stock also increase the inventory waste. When inventory is excessive, it not only increases costs but also leads to the waste of additional resources such as storage space. Therefore, inventory management is an important factor that should be considered to increase efficiency. Overprocessing refers to processes that are intended to create more value than what the customer needs. Eliminating such processes is a critical step to enhance efficiency. First, non-standardized tasks are among unnecessary processes. This may lead to unnecessary extension of processes due to the lack of clear definition of tasks. Another example is painting of surfaces that are not visible or do not need protection. These actions do not add value to the customer and result in time waste. Finally, non-functional additions can also be considered unnecessary processes. These aesthetic elements do not increase the functionality of the product but complicate the production process and increase costs. Avoiding unnecessary processes, optimizing your processes, and improving efficiency provides huge opportunities in terms of both time and cost. Defects refers to any product or service that does not meet the customer's needs. This not only negatively affects product quality but also customer satisfaction. There are many common causes of defective production. First, Non-standardized processes lead to inconsistencies in products due to the lack of proper standardization in production processes. Additionally, untrained or unmotivated staff leads to increased errors when personnel do not receive adequate training, which in turn reduces product quality. Another key factor is the use of poor quality raw materials. Poor quality materials directly affect the final product's quality and increase the risk of defective production. As a result, defective production not only raises costs but can also seriously damage the company's reputation. Motion refers to actions of employees or machines that do not add value to the product or service. Such movements are a significant loss that directly affects efficiency and must be eliminated to make processes more efficient. The main causes of unnecessary movements include inefficient workstation or process design. If workstations or processes are not designed efficiently, employees are forced to make unnecessary movements. Another cause is layout errors. If operators have to walk, reach, or bend too much, it leads to time loss. Finally, searching for equipment is also a significant time waster. When employees spend extra time looking for tools or equipment while doing work, it negatively affects productivity. Eliminating unnecessary movements will make processes more efficient and minimize time losses. Transportation refers to the transportation of materials from one point to another. This process is influenced by factors such as unnecessary transportation of products due to overproduction, the constant need for transportation due to high inventory levels, and the difficulty of transporting materials due to inefficient plant layout. These factors reduce the efficiency of the transportation process, leading to time losses. Waiting refers to waiting for a step in the process to be completed, or working at a low speed, and can seriously impact our productivity. Common causes of waiting include coordination deficiencies, mismatches between operators and machines, unbalanced processes, and malfunctions. These factors prevent processes from operating efficiently. Today, we will focus on the reasons for not utilizing employees' knowledge and skills. Lack of corporate culture is one of the key reasons for this. When there is no culture that transforms the employee's skills into added value within an organization, potential is lost. Employees can be more productive in an environment where they can use their skills. Furthermore, the lack of recruitment and career planning policies hinders employees' development. Offering career development opportunities to employees increases their motivation. Along with this, the lack of a suggestion and feedback system is also a significant factor. When employees cannot freely share their ideas, valuable suggestions are lost, and the development of the organization's improvement remains limited. The main objective of value stream mapping, VSM, is to reveal the value-added and non-value-added steps in the process. This mapping visualizes all steps from the beginning to the end of the process, including the time and information associated with each step. This makes it much easier to observe the process flow and identify improvement opportunities. Understanding which steps really add value at each stage of the process is crucial to making our business processes more efficient. Our goal is to clearly present this value stream and create a smoother process by eliminating unnecessary steps. Just-in-time, JIT, aims to produce only the needed amount and at the right time in the production process. This approach significantly reduces inventory costs by preventing overproduction and makes production processes more efficient. One of the basic principles of JIT is demand-driven production. That is, production takes place only based on customer demand, which eliminates unnecessary stock accumulation. In addition, the JIT system minimizes stock levels and ensures that production is carried out only when needed. This flexibility allows rapid adaptation to changes in demand. JIT also guarantees high quality at every stage by minimizing errors in processes through continuous quality control. Jidoka is a system based on early detection of failures during production and on the prevention of further production until these defects are resolved. The main purpose of this approach is to detect mistakes on the first occurrence and resolve them with early intervention. In this way, potential disruptions in the production process are minimized. For Jidoka to be effectively implemented, every employee must perform quality checks at each step and report any abnormalities in the process immediately. This approach not only ensures defects detection but also provides an opportunity to solve them. Implementing the Jidoka principle increases productivity on the production line while also prioritizing quality. Kaizen is a Japanese term that means continuous change for the better. Its core philosophy is to achieve improvement through small but continuous changes. In this approach, each small step is seen as an opportunity to make a big difference. When we look at the benefits of Kaizen, we can see that continuous improvement stands out as a top priority. With small but consistent improvements, our processes can become more efficient, faster, and of higher quality. Another important benefit of Kaizen is employee involvement. As employees are included in the improvement process, their motivation increases, and their commitment to the organization strengthens. Finally, Kaizen helps reduce costs over time by increasing productivity. It not only improves processes but also helps build an innovative and adaptive organizational culture. This philosophy values the contribution of every employee at all levels and encourages the involvement of each individual in the process. SMED, or single-minute exchange of die, is a method that makes our die change times much more efficient. While in traditional systems, changing a die can take hours, SMED allows us to reduce this time to minutes. There are two key concepts in the SMED process: internal setting and external setting. Internal setting is the adjustments made when the machine is stopped. At this stage, the machine cannot operate. External setting refers to preparations that can be made while the machine is running, which helps to minimize production interruptions. The core idea of SMED is to export internal setting and perform external ones while machines are running. In doing so, we increase efficiency by reducing our total die change time. Additionally, this method enables our employees to take a more active role in the process. Each employee is the owner of the process, not part of it. Improvement is everyone's job, not just managers. Participation fosters a strong sense of responsibility at every level of the process, which enhances the success of the organization. Problems are exposed, not hidden. At this point, making problems visible is a critical step. Transparency and visualization tools, such as Andan boards, support this process. Immediate visibility of problems helps us find quick solutions. Finally, on-site observation is very important. The most effective way to access real information is for leaders to observe the processes firsthand. This method allows leaders to better understand the process and resolve emerging problems quickly. In lean culture, each of these keystones is crucial for continuous development and improvement. Thank you for participating in our training. If you have any questions,